Welcome to The Explainer. Today we're looking at a brand new invention that could fundamentally change the food on your plate by tackling one of its biggest problems, unhealthy fat.
And let's start with a really big number. 2.5 billion. That's how many adults worldwide are affected by obesity. It's a massive global health crisis. And, it's directly linked to the unhealthy, saturated, and trans fats that are in so many of our processed foods.
But food scientists have been working on a really clever solution. It's called oleogels. Now think of them as healthier fats. They're created by taking liquid vegetable oil and turning it into this semi-solid gel that has the texture of butter or shortening, but without all those negative health impacts.
Okay, so here's how we're going to break this all down. We'll start with the quest for a better fat. Then we'll look at the specific scientific puzzle that's been so hard to solve. Then we'll get to the ingenious new solution, the colorimeter. And finally, what it all means for a smarter food future.
Right, so we know that these oleogels are a fantastic idea for making things like cakes and cookies, even burgers, a lot healthier. But there's a catch. They have this one critical weakness that's really stopped them from being used everywhere.
So here's the deal. For an oleogel to actually work, it needs a perfect, stable network of tiny little fat crystals. That's what gives it that solid texture we expect. But getting those crystals to form just right is incredibly tricky to control. If you mess it up, you get an unstable product that can literally leak oil while it's sitting on the shelf.
And as the researchers say themselves, this single problem, this instability, is the main reason these super promising healthy fats haven't become the fat of the future that they really could be.
So to really appreciate the solution here, we first have to understand why this whole process is such a headache for food scientists. It all comes down to the physics of crystallization.
It basically happens in 3 stages. First up is nucleation, where these microscopic little seed crystals start to form. Then comes growth, where those seeds get bigger and start turning the clear oil cloudy. And finally, supersaturation kicks in. That's when the rest of the fat molecules crystallize, and the whole thing becomes opaque and solid. You have to control every single one of those stages perfectly.
And this right here shows you the problem. The traditional tools for watching this, things like atomic force microscopes, are incredibly expensive. They're complex, and they don't work in real time. What the food industry really needs is something cheap, fast, and practical enough to actually use on a factory floor.
And that brings us to the hero of our story, a low-cost device developed by researchers at India's National Institute of Technology, Workala, to solve this exact problem.
It's called the colorimeter. And instead of using all that complex spectroscopy, it uses something much, much simpler, a camera. By just tracking the changes in color and cloudiness as the oleogel cools, it can monitor that whole crystallization process in real time. And what's so cool is how it's built. I mean, this is not some piece of million-dollar lab equipment. It's made from affordable, off-the-shelf parts like a Raspberry Pi computer and a simple camera. Plus, it's an IoT device, which means it can connect to the internet, so you could monitor the process from anywhere. The software they built makes it super easy to use. A technician just punches in a few parameters like the starting temperature. Then the device just takes over, automatically recording color and temperature, and it even generates a live graph, so you can literally watch the crystallization happen. So the idea is brilliant, right? It's cheap, it's smart, it's connected, but the big question is, does it actually work? I mean, can this simple little device really compete with that expensive, gold standard lab equipment?
So the first test was a fundamental one. Can it even measure color accurately? The researchers tested it against a standard commercial device using a set of colored placards.
And the data here is pretty stark. This delta E value measures color difference, and lower is better. The commercial device, well, it was off by a value of over 20, which is a huge mismatch. But the colorimeter had a value under 10. That means its readings were perceptibly close to the true color.
So it's not just a little better, it is in a completely different league of accuracy. The device passed its first test with, well, flying colors.
But here's the most important finding. When they compared the colorimeter's data to results from a Differential Scanning Calorimeter, or DSC, which is the absolute gold standard for this kind of analysis, they found a strong positive correlation. This proves the device can reliably measure the core properties of the whole process.
So for the ultimate real-world test,
They move from their lab-made oleogels to a really complex food product we all know, butter. Could the iColorimeter accurately track the crystallization of milk fat?
And it performed perfectly. The device precisely identified the key temperature points in butter's journey from liquid to solid. It pinpointed nucleation at around 21 degrees Celsius, primary crystallization at 19 degrees, and then the start of secondary crystallization at 15 degrees.
And crucially, these findings were once again checked against that same gold standard instrument, proving the iColorimeter is a powerful and efficient tool that's ready to move from the lab right onto the factory floor.
So what this all comes down to is a really fascinating possibility. By finally giving food scientists a cheap, accurate, real-time way to control crystallization, this simple smart camera could be the key that unlocks the full potential of oleogels, paving the way for the healthy fat of the future to finally show up in the foods we eat every day.